Welcome everyone to another episode where we delve into geodesy and influential geodesists in the world. My name is Mehdi Eshaq, and today we have the privilege of being with Professor Lars Sjöberg from Royal Institute of Technology in Sweden. With a distinguished career, Professor Lars Sjöberg has made a great contribution to physical geodesy, geodynamics, navigation, and applications of mathematical statistics in geodesy. Please join us as we explore his career, insights, and how his research has affected our knowledge in geodesy. Welcome, Professor Sjöberg, and thank you very much that you accepted my invitation to this interview.
No, thank you very much. It's a pleasure.
You have done a lot of work during these years in geodesy. Please tell us a little bit about your journey in geodesy and what was the key motivation which kept you in the subject.
Yeah, it's a long journey. It's more than 50 years now. So, okay. When I was a kid at school, I was very much interested in outdoor life. And in school also, I liked mathematical problems. So a bit later on in gymnasium, I got a brother-in-law that was surveying engineer. So he introduced me to this profession of surveying. And so for 2 summers in gymnasium, I practiced at the local survey office in my hometown and was outdoor most of the time, and I liked it very much. So there was no problem for me to apply later on to come to KTH. That was the only place to have higher exam in master's exam and diploma engineer in surveying. So I spent 4 years for this, and in between 1967 and 71, and then PhD for another 4 years for Arne Bjerhammer, professor there at that time. And after my PhD in 1975, I was a teacher at KTH for some year, and then I spent 18 months at Ohio State University with Richard Rapp, who was professor there at that time. And then back to KTH for 2 years, but between 1980 and 84, I was working with the Land Survey of Sweden in Gävle, and at the same time had an adjunct professorship at Uppsala University, where I spent mostly 1 day per week also. So in 1984, I succeeded Bjerhammer. And well, then I've been the professor at KTH for 30 years until retirement. 10 years ago, I retired. And I've had some work at different universities after that for part-time. That's it. That's my journey.
Professor, what was your motivation? What was this? What kept you active and motivated in the subject? What is beautiful in geodesy, I mean, in your opinion?
I could realize my early expectations. Outdoor life, when I liked, I all the time was, and combination with mathematical problems and technique, which all the time I had the possibilities to. It's my favorite interest from I was a kid, I told you.
During these years, what type of changes has you observed in geodesy or developments? What type of development or changes, I mean?
Yeah, I told you I have a long background, and when I was a student, we had only mechanical instrument and optical instrument. The only electrical one was the geodemeter. It was an EDM instrument, the only one we had. We had nothing but machine computers. Those I don't know what they are named, but there were no electronic computers at that time. When I was a PhD student later on, we had a mainframe computer, but it was very slow. You had to send your punch cards to a data center and you got it back in the afternoon. So one run per day, at most two for trying. So it was only much later that we got our PCs and so on to work with. Another thing was concerning instruments. It was after the satellite era, around 1970, we started to get data from satellites. Both the first positioning instrumentations was Bjerhammer got Doppler instruments. He had 3 of them, and Land Survey had some Doppler instruments. We cooperated with that, but it didn't work very well for surveying, and some national ones for geodesy. But then, of course, quite later, we got the GPS receivers. So we were the first one to have GPS receivers in Sweden together with the Land Survey and also a Space Observatory. Very expensive at that time. And we started up projects with these continued. And satellites, yes, from the beginning, you also got gravity data computed. So it was much later. You got the dedicated satellite mission with gravity data. So we started up early with some geode computations. At the beginning, before the satellites and GPS, the Land Survey said that we have a geode model good to 1 meter, and that's all what we need. But then, when GPS came, they were immediately asking from all over using GPS, how accurate geodes do you have? Can you provide us with a good geode model? And so on. So this was a quick change when GPS came.
So you mean the technological changes in technology revolutionized geodesy, something like that?
It was very important for geodesy, as geodesy is a global subject, really. So in reality, we could do much better work after getting satellite data, both for positioning and for gravity.
So, Professor, how can we explain this to ordinary people? How can we explain this the importance of geodesy to the society?
Well, first you can say that all kinds of GIS data needs position, and it's surveyors, geodesy surveyors that provide you with the coordinates, the positions of your GIS data. Then we need geodesy surveying for all kinds of planning in society, building constructions, and so on. And another example is that if you look at the topographic map, the 0 level there, the 0 of heights, is the geoid. So geoid is now very important topic. And it's the Land Survey that provide you with the topographic maps and so on. Without geodesist experience, I don't think they have experience of the EDM geodymeter I told you. Without their experience, I think that GPS would not have got the very high accuracy that it has today without geodesists, because they knew EDM. They could use more or less the same technique to use the face observable instead of the code observable in GPS, which gave you much higher accuracy that is useful for you need it in surveying, centimeter accuracy, or even millimeter accuracy in geodynamic projects, which you wouldn't have got without the face observable. Also, I think that it was main to geodesists that WGS 84 was realized. it's combination of gravimetric information and positioning information, coordinates all over the world and so on, and other constants.
Lars, I know you. I was your student for I know for you over 20 years. But tell us and tell the audiences. Uh, Amongst those researches and the studies that you have done and what you have developed so far, which one of them you like most?
Well, I think the development of the KTH method for geodetermination I feel is important, has been important. It started already in 1984, so it's 40 years ago I had my first publication on this topic, and been going on since then. It has been a competition with the Danes who used collocation technique, but we insisted to use our own technique. There's also been a competition with the UNB technique in Canada. Well, I feel so. This is important.
Oh, Lars, what can we do
Yeah.
as our younger generation and one generation after you and the generations after me? What is your advice to us? How can we keep geodesy? How do you see that developments of the geodesy and what can we do for geodesy in the future?
Well, I feel that we are now in the era of seeing good results from dedicated satellite missions, and we can do a lot in geo, geodynamics and geophysical work. I think this will continue at all scales, so you can do study seasonal variations by gravimetric data and the combination of GNSS data and gravimetric data we get from satellites gives you good opportunities to study geodynamical phenomena. For example, we recently have published a paper on combining these two for the land uplift in GIS phenomena in Fennoscandia, where we can see the gravity change at the surface from this combination that agrees very well with terrestrial observations, but now we measure all over the area from satellites and GPS points. And we can also from this data estimate what is the density of the upper mantle that we are coming in when we have the land uplift coming in mantle material, and we can estimate this density of it. Geodesists in the future could concentrate on this type of combinations of GNSS data and gravimetric satellite data to many more
Especially
projects. For example, for global change, you can also look on the sea and help in studying the rise of sea level at various places on Earth. You can see water withdrawal. You can well, all kinds of scales and phenomena you can study in this case.
what can we do so that the policy makers and the decision makers can understand the importance of these subjects?
Yeah, this is a very tricky problem. I mean, I just take the example when we started to come up with geode models, more accurate geode models. People were just asking from companies and land survey, well, how accurate geode model can you provide us with? Uh, and but when we were asking for financial support, can we get paid for it to our department? They felt no. Why should we pay? It if you already have it and you have work at the university. It has been tricky all the time to get funding for a small topic like geodesy. We can see it's much easier if you work with GIS. Because it's more obvious that what you provide there. We are working on many times on basic science that is needed for other sciences and for society, but to get the funding is tricky. We have as you know, in IAG, a special communication and outreach branch that should take care of this, and you can look at their objectives, what they try to do to make geodesy more public and open what we are doing. But it's tricky to get the money. Now, it came to my mind that one area that could be of interest to people is the connection to geology and geophysics on MOHO, determining the crustal depth of the Earth, which we have been doing for a couple of years and with some success. If one announced this, it could attract some people that, but from gravity data in combination with seismic data, you reach further than seismologists do. In that respect, that you can have very dense observations, you have the space gravity data, and seismic data are rather sparse and expensive. And from the combination, you can better estimate also the density contrast you have at the bottom of the crust at the MOHO, which you cannot do so well with seismology. So this has been interesting for geophysicists and geologists, what we are doing there. We also need the MOHO for some geodetic problems. So it's a combined problem that more people should work on that too.
If I understand you correctly, you mean that we should work more interdisciplinary and show applications of geodesy in different subjects.
Sure.
Is that what you mean?
Yeah, that's always good. Yes.
Thank you very much for being with us in this interview and for sharing your experiences and your journey in geodesy for us. I hope that it would be interesting for the audiences as well. Thank you.
It was a pleasure to talk to you about these topics.